Hello, Warhawks. This is Mr. Tipton doing a Chapter 9 review over trigonometry, just so you have some extra things in your notes and you can see some examples and have a little more practice with trigonometry before we have a test over it. So one thing that's important here is our acronym that we use to help us remember trigonometry, which I call SOHCAHTOA or SOHCAHTOA, however you want to say it. Usually when I say it fast, I say SOHCAHTOA. But if you have this written down, we can see that SO stands for the sine of the angle equals the opposite over the hypotenuse. CA stands for cosine of the angle equals the adjacent over the hypotenuse. The letter that comes second is always on bottom. And then TOA stands for the tangent of the angle equals opposite over the adjacent. Now, not that I'm really concerned with you knowing these too much, other than just having them written down. But technically, what we call cosecant is the reciprocal of sine. So just have these ratios written down. If you see sine, the cosecant of that would just be it flipped over. It's hypotenuse over opposite. Secant goes with cosine, would be just the flipped or the reversed, reciprocal, whatever you want to say, the cosine, hypotenuse over adjacent. And then cotangent would be the reciprocal of tangent. Instead of opposite over adjacent, it's just adjacent over opposite. But really, this is the stuff that I'm concerned with you knowing, is that SOHCAHTOA part, that sine, cosine, and tangent, which we use to solve trigonometry problems. But just have this written down just for reference. So let's look at some examples here. In cases where we have x is up high, we multiply. So in this case, here's our reference angle, and I kept the same reference angle. We have x would be the opposite side. 12 would be the hypotenuse. If it's opposite and hypotenuse, we know that we're going to use sine. Go back here. We see sine is opposite over hypotenuse. So I'd write it out like this. Sine of my angle equals opposite x over hypotenuse 12. And how we're going to solve this is when x is up high, we're just going to multiply. I'm going to do 12 times sine 50 in my calculator. And that's what x is going to equal. So we'll get back to that in a second. This time, same reference angle, but the sides have changed. Here I have x, which is now the adjacent side, and 12, which is the hypotenuse. So for this question, if I wanted to solve for x, I would actually use cosine. If we look back, cosine is adjacent over hypotenuse. So this one would be cosine of my angle, 50, equals adjacent x over hypotenuse 12. So again, x is up high. We would multiply to solve this problem. I would do 12 times cosine 50 to get my answer for x. And then lastly, this question, here's our angle again. X is the opposite side this time, and 7.7 is the adjacent side. So in this case, if we had opposite and adjacent, we want to go back. Oh, that would be tangent. Tangent is opposite over adjacent, so I'd say tangent of my angle 50 equals opposite, which is x, over adjacent, which is 7.7. So again, x is up high, we'd multiply 7.7 times tan 50 to get our answer for x. Now, I just made all these variables x's, but we moved them around. We can see how we'd use different things in different situations. So go ahead, I'm going to pause the video. Go ahead and see if you can solve these to get the correct answer and check your answer with mine. So these should be the answers that you get. Notice how here we solved for x. It was 9.2, and I did 12 times sine 50. It was 9.2. Got the same answer over here where I solved for the same side because these triangles were all the same. When I did 7.7 times tan 50, I also got 9.2. And then here we did 12 times cosine 50, and I got 7.7. So those are the answers you should have gotten if you did the calculations correct. Make sure your calculator's in degree mode. Let's move on to the next example here. So this time, here's our reference angle. So 7 is opposite of my reference angle, and x is actually the hypotenuse. So if we look at this, opposite hypotenuse, is sine. So we're going to use a sine ratio. So I write out sine of my angle, 20, equals opposite 7 over the hypotenuse x. Now this time x is down low. If x is down low, we switch x places with whatever's over here. So in this case, it's sine 20. We get x equals 7 over sine 20, which really means 7 divided by sine 20. This time, here's our reference angle. 7 is opposite. X is adjacent. So in this case, I look back at my ratios, opposite and adjacent. Okay, that's tangent. I'm going to use the tangent ratio. So tangent of my angle equals opposite 7 over adjacent, which is x in this case. Again, x is down low, so we're going to switch. X will equal 7 divided by tan 20. So go ahead, do these calculations. I'm going to hit pause and then show you my answers. Make sure your answers match mine. Okay, here are my answers. I did 7 divided by sine 20. I got 20.5, which is reasonable. The hypotenuse has to be the longest side. These were actually the same triangles, so for x here, I should get something that's less than this x, which was the hypotenuse. And when I did 7 divided by tan 20, I got 19.2, which again is a reasonable answer for that. Now let's look at the last case scenario. When finding an angle, we're going to use inverse sine, inverse cosine, or inverse tangent, just depending on where our angle is. Here's my triangle. 6 in this case would be the opposite side. 11 would be the hypotenuse. Opposite hypotenuse. I'm going to use the sine ratio. So I say sine of my angle equals opposite over hypotenuse. Your calculator actually won't let you do this backwards because your calculator knows that hypotenuse should go on the bottom. So if you accidentally mess it up, it'll give you an error reading. And then over here, here's my angle. 6 would be adjacent. 11 would be the hypotenuse. So I'm going to use, well, let's go back. Which one's adjacent hypotenuse? Okay, that's cosine. So I'd say cosine of my angle is adjacent, which is 6, over the hypotenuse, which is 11. Okay, so for this angle right here, notice how they're different angles. For this angle, I'm going to use inverse sine. So here's what I enter. Sine -1. It's a secondary function. You hit second sine. And then I want to enter 6 divided by 11 in my calculator. Now, if you have a calculator that doesn't show you all the writing out, like you're using a calculator on a cell phone or something, you're actually going to have to hit 6 divided by 11 equals, and then hit second sine, and it'll give you the answer. Over here, I'm going to use inverse cosine. Cosine -1, and then I just want to enter that fraction, 6 divided by 11. So hit the pause button and see if your answers match mine. Okay, here were my answers. When I did inverse sine, 6 divided by 11, I got 33 degrees. And when I did inverse cosine, 6 divided by 11, I got 56. Notice how these two things actually add up to 90 because it was the same triangle. So if I found this angle, that's 90. And then we have this other angle. All three of those should add up to 180. These two add up to 90. And then again, we have that 90-degree angle there, which makes the whole triangle add up to 180. Okay, review this. If you need help with it, make sure you're getting those answers, the same ones that I'm getting, and we'll see you in class.